So now that we've talked a bit about the difference in behavior between the ArrayList and the LinkedList splitterators, let's go ahead and demonstrate the difference in terms of the runtime overhead of the two different implementations. And so this particular example is kind of a fun one. It's going to compare ArrayList and LinkedList directly on the same input and then see the difference in performance when run with a parallel stream and a sequential stream. So we saw before that the ArrayList splitterator does these nice splits in constant time, doesn't copy any data unnecessarily, and splits evenly. And then we also saw how the LinkedList splitterator does not split evenly, does not split efficiently, and it copies data. So you would expect there to be some consequence of the difference between those two implementations, and in fact there are. And to do this, we're going to take a look at a little program that we'll walk through in a second. And part of the program is going to involve taking a words list, a list of words, list of strings, and then it's going to take that, it's going to be passed in either as an array list or a linked list by the driver program. And then we're going to go ahead and do some work that requires the use of either using parallel splitterators or sequential splitterators. And we're going to go ahead and take a look and see what happens when we use parallel versus sequential and when we use array list versus linked list. So we're going to try all those different combinations. And what you're going to see here, it's a little easier to see on this slide, but then we're going to look through the code in a second. What you're going to see here is that as the number of words we're dealing with gets larger, the win from using parallelism gets bigger, number one, and number two, the win from using the ArrayList splitterator is going to get bigger as well. So let's go ahead and take a look at the example, and that will illustrate the point. And you can find the example here at this URL. So we're now in my IntelliJ project for the EX14 example, and we're going to take a look at this program which shows the difference in performance between using sequential versus parallel splitterators in conjunction with linked lists and array lists. And you can see we're going to read the complete works of Shakespeare as the input. Here's the complete works of Shakespeare. It's about 5.5 megabytes in size. It's all 37 of his plays plus his sonnets. Here's a regular expression that we use to split the complete works of Shakespeare up into the words in Shakespeare. It's a rather obscure regular expression, but don't worry too much about that. And then we come down and run the test program. The first thing we do is warm up the fork join pool, so we'll get consistent results. And then we run the splitterator test. So let's go ahead and take a look at that. So what we're going to do here is we're going to open up the complete works of Shakespeare. So let's take a look and see how we do that. We do that with a little helper method that reads this file, this complete works of Shakespeare, and it turns it into a single string that has the entire works of Shakespeare in one gigantic string. That's a big string, by the way. It's like 5.5 megabytes or so. And then we're going to pass in a splitter, which is a regular expression. And the regular expression here is basically going to be splitting the words, ignoring white space. And I should probably use the actual correct regular expression here, which is this little guy. So that's the regular expression we're using to split the complete works of Shakespeare up into their little chunks. And we then, if you take a look back here, that takes that regular expression and it splits the string into a stream where the stream consists of all the words of Shakespeare. And we get rid of any empty words. We only return up to a limit number of these things, and you'll see why we do this in a second. And then we collect the results into a list of strings. So we have a list of string objects coming back as the results from this method. So what we're doing here is we're going to create the first 1,000 words of Shakespeare, the first 10,000 words of Shakespeare, the first 100,000 words of Shakespeare, and then up to 1,000,000 words of Shakespeare. But there's not 1,000,000 words of Shakespeare. There's, as you'll see, there's around 833,000 words of Shakespeare. These are not unique words. They're just words in general. So now we have an array list of the words of Shakespeare. And then we also create a linked list version of the words of Shakespeare. So we've got an array list and a linked list. And then we're going to go ahead and run this helper program, helper method we'll look at in a second. And we'll pass in the array list first, and then we'll pass in the linked lists. And at first go around, we're going to use sequential streams for everything. And then we're going to go ahead and run this again, next time using ArrayList and LinkedList with parallel streams. And if you take a look, here's the little test program, which takes the name of the test, the words, either ArrayList or LinkedList, and a Boolean flag indicating whether we're running the stream in parallel or sequentially. We garbage collect everything. We update the name of the test to include whether it's parallel or sequential for purposes of the output we get at the end. We then make ourselves a new empty list, and then we do a little fun stream here where we're going to iterate for S max iteration times, which I set to 10. You can make it whatever you want. And then each time, for each iteration, we're going to go ahead and use the stream support.stream helper method to convert the words parameter into a stream. And it uses words.spliterator in order to make it a spliterator for either the linked list or the array list. And then we pass in whether we want it parallel or sequential so that we get the right kind of stream here. And then we're simply going to uppercase each string. Not too profoundly interesting, but just something to do some processing. And then when we're done, we're going to convert the stream into a list. And this is actually an interesting new terminal operation that was added to Java 16 and is therefore available in 16 and later, called toList. And what toList does is it creates a list of, in this case, strings that will be uppercased. And so it's basically a shorthand for saying collect toList. So we don't have to do that. One difference between using collect toList versus just toList, which we do here, is that this creates an immutable list. So you can't change it, which we're not changing it, we're just appending it. OK, so let's go ahead and run the program now that we've talked about what it does, and we'll see the different results for the different sizes of input. So you can see here what we have is we've got the, when the number of inputs are small, you can see the sequential versions are actually faster, which we'd expect. Remember, the way that things work with streams is if you have a very small n, then sequential is often a win over parallel. But as n gets bigger, right, once n gets above 10,000, once it gets to 100,000, then the parallel versions start to excel. And you see the win really coming as you get more numbers of words. So as the number of words gets larger, then the ArrayList version works better than the LinkedList version. Again, just illustrating that when n is smaller, not as much of a deal. Now, the other thing to note, by the way, is that you're going to get better performance if we were to do something more interesting than just uppercasing the string. If you recall the n times q model of performance estimation for using parallel streams, n needs to be big and q needs to be big to get the optimal behavior for parallelism. So in this case, n and q, n is getting larger, but q is not very big because it's not doing very much. If we were to do something that would take longer, we'd get a bigger win from parallel processing. So again, just kind of demonstrating how the difference in performance matters based on whether you use sequential or parallel as n gets bigger, as well as showing how array lists and linked lists behave differently with respect to splitting.